The Pool Guy Podcast Show. The Pool Guy Podcast Show. The Pool Guy Podcast Show. Yeah!
Hi, welcome to the Pool Guy Podcast Show. I'm going to answer the question that I get asked all the time, and I see a lot of myths out there, and there's some truths also. But do variable speed pumps actually save the customer money? Will save you money to go from a single speed pump to a variable speed pump. And of course, if you go to the manufacturer's website, some say you'll save 90% of energy use, some say 85%. So what are the true savings on real life energy use in a real pool situation? Pool Service Pro. Open a Leslie's wholesale account today and receive wholesale pricing on products you use every day. Leslie's Pool Supply offers convenient locations that are open 7 days a week. Another great benefit of opening a Leslie's wholesale account is Leslie's referral program. Get referred to a customer looking for weekly pool service. Save time and money and grow your pool service route and become a Leslie's Pro. So a couple of years ago, the U.S. Department of Energy mandated that pool pumps become more energy efficient. And this pretty much eliminated all single speed pumps over 1 horsepower because they're not energy efficient enough to fit their criteria. I don't know how far they've gone cracking down on this, but they were going to fine manufacturers and distributors that put out these pumps that weren't energy efficient, which means that most consumers were forced to adopt variable speed pumps or a dual speed pump. And I don't think this policy has been strictly enforced. I can still get a 2 horsepower pump just about anywhere, single speed pump. And a lot of manufacturers or distributors are just recategorizing the pool pump into the swamp cooler category, or they're finding ways around it. Above ground pools or pumps are exempt. So you can classify your pump as an above ground pool only pump and probably get away with it. So that doesn't leave much strength in the government regulations. But the variable speed pumps have been pushed on us a lot of times by just the fact that this is an option that would be a money-saving option for you, and therefore you should spend the extra money to get the ability to save money on your energy bill. And that's probably not the best way to sell it, but I'm just boiling down the points of the sales pitch. Pay more money up front for this pump. That's going to save you more money on the back end on your energy bills. Now, is the upfront cost or extra cost of a variable speed pump really worth it? And is the back end savings really going to pay for the pump in 2 or 3 years? And my answer to you, that all depends. It depends on how that pump is set. A lot of builders will put these in and they'll run them at the full speed. And I've taken over accounts before where I get back there and there's a variable speed pump running at 3450 RPMs, which is the maximum speed of that pump and of a single speed pump. And I'll look to the programming and there's no secondary program in there. Everything was just that one program because they want to make sure the pool has circulation and they don't want to mess with setting anything. And they don't care about any energy savings for the customer technically. So they'll just set it at a high speed or higher speed. And this is where I say that it really depends on what you set the pump to, and that will correlate to energy savings. Now, reading the fine print in the brochure is really important here because if you look at a brochure, let's say for the Pentair Whisper Flow VST pump, it says you'll save 90% in your energy use costs up to 90%, save up to 90% in your energy use cost. Then if you look at the small print, it says, saving based on variable speed pump compared to a single speed pump running 12 hours per day at an average of 0.16 per kilowatt hour in a 20,000 gallon pool. Actual savings may vary based on local utility rates, pool size, pump runtime, pump horsepower, pump RPM, plumbing size and length, pump model, service factor, and other hydraulic factors. So that's a lot of variables in there to get to that 90% of savings. And I would say saving 90% on your energy use is highly unrealistic, and it's not going to happen in even the best case scenarios. For example, the 16 cents per kilowatt hour is way below what we pay here in California. And the other factors, of course, besides how much you pay for kilowatt hour, is the pool size and runtime. So let me back up a little bit and talk about the runtime of variable speed pumps to kind of give you an idea of how you can save energy. And I would say that you're going to save a good percentage, maybe 60%, maybe 50% on your energy use, maybe even up to 70% if you set your pump correctly. But the lower RPMs that you set your pump for equals the more savings. However, and here's the caveat of the VS pump, the lower you set the RPMs for, which is the speed of the pump, the lower the flow of the water going through the pump to the pool will be. So if you set your pump at 1600 RPMs, it's probably only moving about 20 gallons per minute at the most, maybe less, versus a pump that's running, a single speed pump running at 3450 RPMs is probably moving anywhere from 80 to 90 gallons. I would say the average is probably about 70 gallons. And so you're moving about 4 times more water at the full speed. That means that if you're running your pump for, let's just say 10 hours a day, and you're running your pump, single speed pump for that long, and then you have to divide that by 3, that means you're going to run that pump at 1600 RPMs for 30 hours to get the same turnover you would get with 10 hours. Now that's unrealistic because only 24 hours in a day. So you're going to have to up the speed of that pump to at least 1800 RPMs. And that's the minimum speed that I would set a VS pump at. I wouldn't go below that because you're still getting decent flow at 1800 RPMs because you're kind of cutting in half the 3450 RPMs to get that. And you don't have to run the pump for 30 hours a day to get the same turnover. If you just use basic logic when you're setting the run times, let's just say that you run your single speed pump, and we'll keep it simple that you run it for 10 hours a day. You have a 20,000 gallon pool, and you're running that for 10 hours a day. What speeds would get you to the same turnover? Well, if you run it at 1800 RPMs and you don't have any other speed, that means that you would run that for 20 hours to get the same turnover you would get at the 3450 RPMs. You're just doubling that. But you can also do a 2-program setup where you have the pump running for 10 hours at 1800 RPMs, and then you're going to run it at 2600 RPMs for 4 hours. And that's going to equal the same runtime that you had your single speed running at. Now here's where you save the money on energy, because let's say you're running your pump at 3450 RPMs, you're probably using, I don't know, anywhere from 800 to 1,000 kilowatt hours per kilowatt hours of power per hour. Now it doesn't translate directly from watts to kilowatt hours because you have to run it through the formula. But let's just say that you had, 10 100 watt light bulbs running to equal the pool pump running for that 10-hour period. So you have 10 100 watt light bulbs, which is 1,000 watts. Again, doesn't translate to kilowatt hours directly. And then you had your pump running at 1800 RPMs. And let's just keep it simple. Let's just say you had one program at 1800 RPMs running for 20 hours a day to equal that. Now you may think that you're using very similar wattage because you're thinking, 3450 divided by 2 is a little bit less than 1800. So if I'm using 10 100 watt light bulbs running the pump at 3450 RPMs, by cutting it in half to 1800 RPMs, I'm going to be using 500 watts. But in actuality, you're using about 250 watts. Now, each VS pump's different, but some will display the wattage being used every hour it's running. And this is a pretty good number, 250 watts. And so you're not actually just saving half the amount of wattage per hour. You're saving up to 75% of the wattage that you're using on your pool pump as a single speed. So the savings are tremendous if you look at it that way, because lowering the RPM doesn't directly correlate with cutting the wattage in half. It actually cuts it more than half, more like 3/4. And so you're basically saving a lot of energy by running your pool at the lower speed. Now here's where, when I said at the beginning, it depends. So if you're running your variable speed pump, let's say you have one program at 2600 RPMs, and you have another program at 3100 RPMs, the savings there are going to be a lot less than you running a different program where you have 1800 RPMs as your low speed and then 2400 RPMs as your high speed. And you're going to save more money with the lower RPMs over time, running it longer than running it at a higher RPM for a shorter period of time. I know it's counterintuitive because you're not dividing everything in half. You're actually dividing it by more than half. and up to 75%. So I think the biggest challenge is to set the variable speed pump where you're going to recapture the most money, and that is at a lower RPM. So for example, I have a variable speed pump in my house, and I'll run it at 1800 RPMs for a long period of time. Depending on the season, I'll adjust it down. And then my high speed is only 2400 RPMs. And again, I'm saving a lot more energy because I can correlate that. When I had a single speed pump, I took the electricity bills 3 months prior to that and I counted back, and I took it over last season. And then when I put the VS pump on several years ago, I can see right away that the kilowatt hours I used dropped. Again, this is an overall picture because your air conditioner, your refrigerator, everything you're running in the house adds to that. And so it's kind of hard to separate the pool pump from that. But I can tell you that I saw a noticeable drop in the overall bill after going with the VS pump than before. There's nothing else that I can correlate it with except switching from a standard single speed pump to a VS pump. And you can do the same thing at your house. Before you put one in, take your last 3 electric bills or go back to last summer, keep track of that, and then going forward with the VS pump, keep track of the power consumption. Now, every summer is different. Some summers you're going to run your air conditioner more than others, depending on how many heat waves you get. Now, if you're in Arizona, there's probably no difference between one summer and the next. But here in California, there are differences. One summer may be really hot, the other summer may not be. So it's going to be hard to correlate that based on your air conditioner usage. But I can tell you that just looking at the pump itself and looking at the wattage it's displaying on the screen should be enough for you to understand that you're saving money running your pump at a lower RPM. It's the same thing when you're driving your vehicle. If you have a vehicle that has the mileage calculated for you, you'll know that when you're on the freeway, you're going to get better mileage than when you're driving on the back roads. So if, let's say you spend a week driving around the back roads, you're averaging 18 miles per gallon. But then the next week you're taking a few road trips and you're on the freeway, and then you're averaging 22, 23 miles per gallon. So you can see how that kind of saves you money on gas. The same thing goes with the variable speed pump, except it's the opposite. So the lower or slower you're going, the more money you're saving on energy. So you should be setting your pump so you can recapture most of the energy use by balancing that out with the water quality. For example, you don't really want to run a program of 1800 RPMs for 20 hours a day, because then the skimmer never activates really powerfully to pull in debris. And then if you have an automatic cleaner, like a suction side cleaner, it's not going to have enough RPM to move it. And then the water quality will suffer because the dirt will settle to the bottom. Leaves will settle to the bottom. You're going to have to use more chemicals because you have more organic debris in there. And so you have to get a balance to where you're saving money, but the water quality or the look of the pool doesn't suffer. Now, when these first came out in the market, the thinking was, well, let's just run these at low speed all the time. And if you ever had a pool with a dual speed pump, you're going to realize that, 1100 RPMs doesn't do much. You might as well, or 800 RPMs, depending on what the low speed is set on a dual speed pump. You might as well just turn it off after the pump, the initial first speed or the higher speed is running, because the lower speed doesn't do anything to the water. And the same thing with a VS pump. If you're running it like 1400 RPMs or 1600 RPMs, you're not going to have much surface movement. So when these first came on the market, a lot of builders would set them at 1400 RPMs for 12 hours a day, and then they would set them at 3100 RPMs for like 2 hours a day. This wasn't doing anything to the pools. People were complaining about how bad their pool looked with the VS pump, and so the manufacturers had to kind of reevaluate things and change things a little bit. And so a super low speed of 1400 or 1200 just doesn't work. It doesn't move any water, and you're going to just have a really ugly looking pool. So I would say 1800 RPMs would be my minimum, which is about 230 watts. And then you would pick your next speed depending on what you need. If you have a suction cleaner that needs some power, maybe 2600 RPMs. If you have a water feature or waterfall, maybe 3100 RPMs. It just depends on the pool setup. But the majority of the runtime should be at the 1800 RPM mode or point to save the maximum amount of money. So maybe 12 hours at 1800 RPMs, and then 4 or 5 hours at the higher speed, or 14 hours at 1800 RPMs and 3 or 4 hours at the higher speed. Basically, you need that higher speed so the pool doesn't look bad, and you need to really circulate the water. I think you should circulate the water at a higher RPM every day just for the water quality and just for the cleanliness of the pool. Something that you don't think about, and when you're buying a variable speed pump, this is something that is probably not on your radar much, but if you have a single speed pump, you know that that motor burns out or wears out within 4 or 5 years now if you're lucky, and so you're changing that motor more often. With a VS pump, since they don't run at full speed and they also have a different voltage configuration, the motor will last a lot longer than your typical single speed motor in most cases. And you're going to find that the VS motor, as long as the drive doesn't go out on you, which is it's a very expensive hit, you must buy a whole new pump at that point. But as long as that drive lasts and the variable speed pump motor is being maintained properly, you're not letting the water level drop really low and having the pump suck air all the time. And as long as you're maintaining your pool, this VS motor can last maybe 3 or 4 times longer than a single speed pump motor. I've seen it in real life here. I've been doing pools long enough to where the first Pentair VS pumps came on the market. They were okay. They had a few drawbacks. They had a problem with the alarm going off all the time and not going back into run mode. But some of these are still on the market, or in people's backyards today, I should say. And they've been on the market for a good 12, 15, 20, almost 20 years now, I would say. And these are still operational. And you rarely will be changing out a variable speed motor if you don't have a defective one. More than likely, the drive is going to fail a lot sooner than the motor itself, and you'll be changing out the pump because of that reason. So the motors seem to last a very long time on these variable speed pumps. You don't see a lot of problems with the bearings. You don't see a lot of problem with them wearing out or having problems because they're a little different than the single speed pump. And a lot of them now are totally enclosed, fan cooled, which a lot of single speed pumps are also that way. So you're going to have the extra weather protection. But bottom line is, if you've been changing out your motor every 4 or 5 years, that money you spend on that is better off invested in the VS pump. It's going to last a lot longer. So you're also buying a higher quality product that's going to last a lot longer if you buy a reputable variable speed pump. And I would say getting them from the big 3 manufacturers would be the easiest way to get around failure or fail points, Pentair, Jandy, or Hayward. I noticed when I was taking the WhisperFlow VST pump apart for the video I was filming that the actual motor is from Nidec. And this is the company that has been emerging for a long time, and it's actually, the old company was called US Motors. So if you're an old pool guy, you know US Motors. But Nidec has been the parent company now for a few years. And it's interesting that Pentair went with this particular motor over the Century motor. But I do know that Nidec had moved to Mexico and they're making the motors there. So that may be a factor. But the bottom line is you're getting a high quality product and you're paying for something that's going to last you a long time. So that's something to consider also. The initial investment is going towards a better product overall. Also, you don't have to worry about having a separate timer with one of these. In most cases, unless you have a salt water generator. A lot of these will have an auxiliary relay where you can actually wire in the salt generator so that when it reaches a certain speed, it'll turn on and turn it off. There are also some tech advantages of having a variable speed pump. Some of them are app controlled. You can also, like I mentioned, connect other devices to the back of it, like a pressure side cleaner or a salt system without having to have a separate timer. And also, you can also have the timer set and you can run programs, and it's all digital now. So there are some distinct technical advantages of having a variable speed pump. Besides just the energy savings, you have an easier to program cycle, and you can have more than one cycle. You can have it run in the morning, in the afternoon. You can have it turn off for a few hours and come back on later. So there's more options with the variable speed pump, and you're getting more tech along with the VS technology. And so back to the beginning where I said that will buying one of these pay for itself in 2 or 3 years? I think if you set the run speed correctly, if you have the right size pool and you buy the right size variable speed total horsepower VS pump for that pool, and you set it logically, I think you can definitely recoup most of that money in 2 or 3 years running it at really consistent speeds. It all depends on those factors: time of year, how long you run it, what speeds you put it at. But in the long run, you're going to definitely recoup your money, and upgrading to a VS pump will definitely pay for itself in the respect that you're not swapping out motors every 4 years. You're getting a high-tech product that you can program, sometimes through an app, sometimes at the controller. And you're also getting energy savings that are really verifiable if you are able to get your bills and look at them carefully and split that. Probably the best thing you can do for a test is to get a duplex meter put in at your house. Now, Edison in my area will do this for you. They do it a lot for electric car charging to get the rebate. But if you really wanted to see how much the pump is costing you, have a duplex meter put in. Of course, you're defeating the savings because it's going to cost you a lot of money to do this. But if you wanted to do this test, you can have the pump on a separate meter, and then you can really correlate the savings on energy use. But no one's going to spend $3,000 or $4,000 to get a dual meter put in to test this. The best way you can test this is you looking at your bills. And I can attest to the fact that you are going to save 50 or 60% on your usage of your single speed pump versus the VS pump. To get to the 90% would be difficult, but probably not impossible if you have the right parameters. But bottom line is you're going to save on your kilowatt hour usage by going to a VS pump just by looking at the amount of wattage you're using on lower speeds compared to the amount of wattage you're using running your single speed pump at 3450 RPMs. And I would say the answer to the question, will a VS pump, variable speed pump, save you money? And the answer is yes, it will save you money. How much depends on all these factors. But to me, I think it's well worth investing in it because you're getting a really reliable product that's going to eventually, over the course of 5 to 10 years, save you a considerable amount of money over your single speed pump. If you're looking for other podcasts I recorded, you can find those on my website, swimmingprolearning.com. Just click on the podcast icon. That'll take you to a drop-down menu of other podcasts I recorded. And if you're interested in the coaching program that I offer, you can learn more at poolguycoaching.com. Thanks for listening to this podcast. Have a great rest of your week, and God bless. Real quick, if you're not using pool service software, try Skimmer free for 30 days at getskimmer.com/poolguy. Again, that's getskimmer.com/poolguy. Skimmer, everything you need to run your pool service business all in one app. Pool Service Pro. Open a Leslie's wholesale account today and receive wholesale pricing on products you use every day. Leslie's Pool Supply offers convenient locations that are open 7 days a week. Another great benefit of opening a Leslie's wholesale account is Leslie's referral program. Get referred to a customer looking for weekly pool service. Save time and money and grow your pool service route and become a Leslie's Pro.